In this video, we're going to do question 15 from homework 10.2. So we are asked to use properties of exponents to simplify the following expression as much as possible. And again, we are assuming that the x's and the y's are positive. Before we do this exact problem, let's recall some laws of exponents. Right, so in preparation for question 15, what if we had this problem? X squared times y to the fourth divided by, right, dd, division by my denominator, divided by x cubed times y. The only difference between this problem and problem 15 is that these numbers up here are fractions. Okay. X squared is x times x. Y to the fourth is y times itself 4 times. X cubed is x times x times x. Then we're multiplying by one more y. You can see that we have secret times ones here. And what's left over is a y times y times y in the numerator and an x in the denominator. Right? Now, the shortcut is to have, we've got x squared over x cubed and say that that's x to the 2 minus 3. And y to the fourth divided by y, that's y to the 4 minus, remember right here, y is y to the 1. Okay? 2 minus 3, 4 minus 1. Order matters in subtraction. I'm doing the numerator minus the denominator there. So we get x to the minus 1 times y cubed. X to the minus 1 is notation for the reciprocal of x. Multiply fractions straight across and you see that you get the same thing. Might as well do it in the same color. Right? So we're going to do the exact same work here. I can't write out these repeated because now we're going to have fractions. I can't say x times itself 3 times. So my approach is going to be using my laws of exponents. But all I'm going to do is I'm going to subtract the numerator exponent from the denominator exponent for x being the base, do the same thing for y, and simplify. So let's even see if we can have it on the same screen. And this is multiplication. So this is x to the 1/3 minus 5/6 times y to the 4/5 minus 2/3. Okay. And it might look ugly, but really this is back to the beginning of the class where we were practicing subtracting fractions. If you would like and not do all that work up tiny in the exponent, you could do a little bit of scratch and say, what the heck is 1/3 minus 5/6? And then what the heck is 4/5 minus 2/3? Let's go ahead and do that. I need a common denominator here. 1/3 is 1/3 times 1 in the form of 2/2. So we've got multiply fractions straight across. We've got 2/6 minus 5/6. 2 minus 5 is minus 3/6. Common factor of 3 there. This simplifies to minus 1/2. Right? So 1/3 minus 5/6 is minus 1/2. So I know that I've got x to the minus 1/2 power there, which we can simplify. Let's go ahead and do some scratch for 4/5 minus 2/3 as well. All right, so the least common denominator between 5 and 3 is 15. If I skip count by 5s and skip count by 3s, the first number that they have in common, their least common multiple, is 15. So 4/5 is 4/5 times 1 in the form of 3/3. And 2/3 is 2/3 times 1 in the form of 5/5. Multiplying my fraction straight across, I see that 4/5 is equivalent to 12/15. I have 3 times as many slices of cake, but they're a third as big, so I haven't gained or lost anything. Minus 2/3 times 5/5. Multiply fraction straight across, 2 times 5 is 10, and 3 times 5 is 15. I have 5 times as many slices, but they're a fifth as big. I haven't actually changed 2/3, I've just changed the way it looks. Bloop. 12 of these things minus 10 of these things is 2 of those things, and those things are 15ths. All right, so now let's put this, I think that was worth doing as scratch work. Maybe I'll even bubble it all in. So here we have it. I'm going to duplicate just so we're not scrolling too much. X to the yellow is x to the minus 1/2 times y to the orange. Orange is 2/15. All right, and now I would like to deal with that negative exponent. That's 1 over x to the 1/2. Remember, negative exponents are just notation for reciprocal. And we can go ahead and multiply these straight across. All right, so we're almost done here. Multiplying fractions straight across, I have my answer, y to the 2/15 all over x to the 1/2. And we're done. And I want to practice entering that in to the computer. Now, I've been playing around a little bit. It does accept y to the 2/15 all over x to the 1/2. The computer likes that. It also likes y to the 2/15 and to the 1/2 power is square rooting. But the one that the computer's not super happy with, and this is true, remember the denominator is the root that you're taking. You can say this is the 15th root of y squared, and the computer's not thrilled with that. Although I'll bet most of you would have gone ahead and probably just stopped right here. Let's go ahead and enter those into the computer. All right. So in my answer field, I'm going to go ahead and hit the yellow arrow and then my fraction bar. My numerator, I want to be y to the 2/15 power. And you can do that. You hit y, and then this button right here gets me up high. And I'm going to do 2 divided by 15, or if you want to insert a fraction, you can like that, 2/15 power. In the denominator, I want x to the 1/2, so I'm going to hit x, this button right here to get onto the exponent. Coming up, I'm going to do 1/2 power. You could do 1 divided by 2, but remember you want to make sure that you put it right there, or you could use your fraction symbol there. Save. That's exactly what I want it to say. I'm going to hit submit. And you see that we did great. Now, alternatively, your computer would have accepted that square root of x in the denominator, but I got to put it there. Square root button, come inside that field, square root of x, save. That looks great. It likes this one as well. Beautiful. But what didn't go through so nice, but I do feel like showing you how to enter it, is in my numerator having the 15th root of y. Do you see how this guy says the nth root of x? That means I can put in any root that I want, not just square root. So if I hit it, it defaults and it puts a 3 there. If I go on top of it and I back up and I want the 15th root, I can put a 15 there. The 15th root of y squared in the numerator and square root of x in the denominator. This is beautiful, and I think that's good to know how to enter in, but what's going to happen is the computer wasn't programmed with this option. But I think most of us would have just stopped with those fractional exponents. So this is not wrong, it's just the nature of technology. All right, so that concludes our video for problem number 15.